All right, good afternoon, guys. I think I've waited long enough. No, 17 minutes passed. My two first ones out of the bat were Jermaine and Nestor. Welcome, welcome. Trust that you had a good day at work today and are ready to go. How are you doing tonight?
I'm doing fine.
Good job. Good, 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 good. I am happy for that. I'm also very encouraged, and I also use the time for you to get a little breather between this class and the one you had previously. So now, how many of you got an opportunity to look over what it is that we did in class last Tuesday?
Anybody? Somebody?
Sorry, I didn't look over, but I remember what we did.
You didn't look over. Okay, Charlene. Appreciate your honesty. And oh, the devil is a
Same thing here,
liar.
sir.
The devil is a liar. I just got some coconut water to refresh myself in class, and I just spilled the whole of it inside of the plate. Do me a favor, guys. They get 3 minutes, please. Oh my goodness. Hold on, guys. Sorry about that here, guys. Me say the devil wicked. Him no say my bembe very delicate, and he make the coconut water throw it right on something. Anyhow, ouch. Let us see what will happen. All right, so I think Charlene was saying that she didn't look over, but she still has an idea
Sorry, I
what it
don't
is.
know if it's me, but you sound really low.
Yeah,
Yes, sir.
hold on, hold on,
Yes,
hold
you're
on.
lost.
All right, am I any better now?
Yes, a little bit.
All right, cool.
Barely, sir. Barely.
Barely better, jeez, but I'm hearing you so well. Barely better. All right, let me just try. All right, how is how is it now?
Yeah, that's
Yes,
better,
sir.
sir.
Yes, sir.
All right, good. All right, yeah. So you were saying, Charlene, that you didn't get a chance to look over, but you still have an idea of what we did, and that's fine. So tonight is the night when we are going to, when the tire really hits the road, when the tire really hits the road, and we have, quite a bit to do. All right, so you know what is happening here, so it's a good thing that I'm having this, doing this stuff from the tablet because the computer has to shut down because it's not responding. Anyhow, right. So we looked at some limits. Now let me just use this here as um, my little writing space until the tablet comes back up. All right, let me just log log in as host, playing host role. Let me see if I can do that. All right, so I'm now the host. Let me see if I can. Oh, 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 oh. All right, so you guys must be saying that I am very unprepared for tonight, but you will not understand from minutes to 7 o'clock. I logged on and everything seemingly was fine until I'm ready to begin. Shauna Lee, you are here for the first time. We are going to charge you bus fare.
Sir, you gone back down low, sir.
All right, there's all my own. All right. Ah, Andrew Cameron, you are also new. This is your first class. I don't remember those names at all.
Yes, that's correct, sir.
All right. Welcome. All right. So let me just walk you through what it is that we did. My Bembe is taking its own little time to reboot. So let me just walk you through what it is that we did until it comes up so I can start to write. Um, so we looked at the intuitive, well, we looked at two approaches on Tuesday. We looked at the intuitive approach and we looked at the algebraic approach. Now, the intuitive approach, what it says, if you're finding the limit as x tends to 2 of x plus 1, and I'm changing it up to say x plus 1, x tending to 2 doesn't mean that x is equals to 2. X approaches 2 does not mean that x is 2. It says what it is. It is approaching 2, it is tending towards 2, it a along to 2, but it not reach 2. All right? So from the left hand side, I must investigate the limit from both sides. And from the, and this concept is going to be very important, especially when we move on to piecewise function. And because you're a calculus one, and because we have a long syllabus to complete, I am not going to be tarrying really around areas that you guys should know. So come tonight when we have an extended class, I am hoping to get through as many of the different variations on the limit so we can even touch on a little piecewise function. Now, when we're doing a piecewise function, we have to look at the function as it suggests, piecewise, little by little, from the left, from the right. All right? So it's important for us to, just like when you're growing up and you crossing the road, I'm saying when you're crossing the road, I'm sure all of you got this when you're going to basic school. Look, them don't say look left and look right, and them say look up and look down, and then look up again. So you have to look at both sides to see that both sides are clear so that you can go across the road. All right? It's the same concept with the limits. I have to look at both sides, the left-hand side, and I must look at the right-hand side. Now, if when I calculate the limit on the left-hand side, and the limit approaches or tending to a particular number, best believe that when I calculate the limit on the right-hand side, it better approach the same number. If it doesn't, my conclusion is going to be that the limit does not exist. My conclusion will be the limit does not exist. The conclusion will be the limit does not exist. Why is the limit non-existent, sir? Because the left-hand side is not equal to the right-hand side. So we say that the limit is of a bad behavior. All right? Now, if when we do the calculation on the left-hand side and the calculation on the right-hand side, and both answers are tending to the same number, we will say that the limit is of a good behavior and that the limit does exist. That the limit exists. All right? So just remember, the limit must, in order for the limit to exist, it must be tending to the same number from the left-hand side and the right-hand side. What happens, sir, if the limit does not approaches to the same number when we do the calculation? Thanks for asking. It's not a problem. Our simple conclusion would be the limit does not exist. All right? So I'm going to ask you to do the intuitive approach for me for this question. My system is still coming up. Write for me, please. Limit x tends to 3 of 2x plus 5. I'm going to ask you to use the intuitive approach to evaluate the limit as x tends to 3 of 2x plus 5. The limit as x tends to 3 of 2x plus 5. As soon as my system comes back up, I will work through the question with you. But just do it in the meantime for me, please. The limit x tends to 3 of 2x plus 5. Start for me. Okay. Let me see if I can bring this thing to
Sir, which approach you should be using again?
the intuitive approach. Come on. All right. Has anyone completed the question?
Sir, I'm doing the right side.
Okay, good. No problem. Take your time. The rest of you, please ensure that you are working. All right. So let us go. Let us go.
So I'm almost on the right side. Give me a minute, let me see if me a shot.
All right. Cool.
Yes.
Sir,
Yes, please.
it can still be wrong even if the two sides are equal.
It can be what?
Can it still be incorrect even if the two side equal? Can the answer still be incorrect?
But I don't get it. The answers to be incorrect if two sides are equal, or
Sorry,
is
you're
it?
low, so I can't hear you.
All right. I don't know what to do right about now. Uh, all right. Nestor, I hear me better now.
Yes, sir.
All right. Say it again, honey. You're saying that if I could be wrong if the two sides are equal? When it's a wrong, what you mean?
Yes.
When it's a wrong,
So
what you mean?
even though the two sides are equal, can the answer still be incorrect?
No, man. No. Mm-mm. You're checking to see if the limit exists, you know. And one way to check to see if the limit exists is that both sides must be the same answer.
Oh, okay. Okay. Understand.
Yeah, man.
All right, sir. You can proceed. Let me see if I'm wrong.
I'm finished.
Okay, good. All right. So, so
Yay.
all right, so let's go. So from the left hand side, x approaches 3. So I am guessing 2.9, then 2.99, then 2.999. And from the right hand side, I'm approaching 3 from the right hand side. I am going 3.1, 3.01, 3.001. So you are going to work your calculators for you. I can't find my calculator. So you're going to say 2.9 times 2 plus 5 equals
10.8.
10.8. I'm hearing
Yeah.
10.8. All right. I'm hearing 10.8. 2.99 times 2 plus 5 equals
10.98.
10.98.
up 10.98. Now, watch me. You notice right here, I have something there as 11
Yeah.
Sir.
because I'm
Oh.
guessing that is going to go to 11. Well, actually, I'm not guessing. I actually look at the limit another way, and I'm going to say something. I'm just going to be up and frank with you.
Whoa, sir. Oh, sorry.
There are several methods to do a particular question, you see? And
Yes.
if you
Oh.
can do, they will say to you, give me the solution to this question using this specific method. But if you can work the other method, work it using another method in your headspace, and you know what answer is supposed to be working towards, hooray for you. All right. So because I know another method in my headspace, I use that other method quickly, and I say, okay, the limit is going to approach 11. Let me use the method that they're asking me to use now to see if I really get 11. So let us look at it. 10.8. And then my second calculation is going to 10.98. And without even me asking you now, I am going to hazard a guess for this one here to be 10.998. Talk truth.
Yes, sir.
Yes, sir. And if I do 2.99999, I'm going to get 10.9998. All right. So if you see what is happening from the left hand side, my limit is getting very close to which number?
11.
11.
11.
So I can say this is approximately 11, right? So I have that there. So I'm going to investigate the right hand side. The right hand side better approach to 11. If not, it means that the limit does not exist. So let's go. 3.1 times 2 plus 5 equals
11.2.
11.2. But sir, or you say it's supposed to be 11 and it gone 11.2. Remember, you know, when we're doing the investigation or initial start, most times it's not going to be close to our answer. We have to go into the investigation in order to see what is happening. All right. So let us try this other one now. 3.01 times 2 plus 5 equals
11.02.
and then I'm going to get 11.002. So you see what is happening now? So this limit approaches to what now?
11.
11. Very good. So I can say with clarity of mind that since the limit as x tends to 3 to the left of 2x plus 5 is equals to the limit as x tends to 3 to the right of 2x plus 5 then the limit tends to 11. Right? Both are equal. All right. So the limit of this function, it does exist. Why, sir? Because both of them tend to the same number. And what is that number, sir? It's number 11. So the limit of that function is 11. Now, I don't want to seem as if I am showing off on you, but I want you to be able to show up on yourself. And I'm doing both methods simultaneously because I want you to be able to get what is happening. The calculations method. Calculations method. The limit as x tends to 3 of 2x plus 5. Now, hear me out, and I want you to hear me well. X tends to 3. I am doing the calculations method. I am going to assume that x is equal to 3. Press pause. Class, is x equals to 3?
You're going to replace the x.
Yes, sir. Yes, sir.
Hold up.
2, 3, 6 plus 5 is 11.
No, man, hold up.
No, x is not equal to 3, sir.
Thank you very much. X is not equals to 3. X is only approaching 3. But for the sake of this calculations method, I am going to assume that x is equal to 3, but x is not equals to 3. All right, let me see if I can develop that concept because I really want you to understand it. Aha, I have an example. So me and you go to foreign, not times like no, when them have to get the juke and them something there. But me and you go to foreign. We don't live into foreign, we live into Jamaica. And we don't have no foreign issued credit card. But we have a credit card and we have enough money on the credit card we can survive. Eh? We go to a place to shopping. And when we shopping, the man them say $195.95. You say below $195.95. My question to you, are they taking $195.95 from your Jamaican card?
No, sir.
No, sir.
What are they
No,
doing?
you're taking the equivalent.
Very good. So they will have so what is happening? And if you have a good credit card, I mean I say a good credit card, what the credit cards are the credit card companies are very smart. What they will say to you is, are you paying in Jamaican or are you paying in US? All right? Now I'm going to tell you a secret. Never ever say that you're paying in US. Always pay in Jamaican if that is the case. Because the paying in US, it means them will hold it until you're clearing the bill. So you're spending 2 weeks of foreign. It means that they're going to hold the US on the card for 2 weeks later. And when you come back to Jamaica, the dollar gone up by $5 more. So you're going to pay the US dollars at that $5 extra. Am I making any sense? So the US dollars is 50 to 1.
Yes,
because
sir.
you click say paying in US dollars, but 2 weeks later when you come back, the US dollar gone to $55. Don't think it's $50 again pay that now. It's when you clear the bill, that's what you're going to be paying at. So when I click Jamaican dollar now, I am getting the rate at the same day I am making my purchase. So if there is any increase in the US dollar, the exchange rate, it does not affect me because I already clock it in at that particular rate. All right. So this is how the credit card companies make their money. So the truth of the matter is that $195.95 you are not paying in is not that they're taking from the card. They're taking the Jamaican equivalent from the card. But guess what? You can assume that $195 is coming off the card. But really and truly, it's not $195. It's going to be $195 times about 165 right about now. All right. So So even though you know what is coming on the card, you may even say to yourself, all right, based on the amount of Jamaican dollars I have on the card, when I convert it, it amounts to $500. So $195.95, call it $200. So you know in your headspace, so you say that you have $300 to spend because you're now in a foreign country when you their denom. So just like this now, x is not equals to 3. X is only approaching 3. But for the sake of the calculation, just like what I'm saying to you, me knows that me have X amount of Jamaican dollars when me touch down in a Fort Lauderdale. And me said to myself, all right, the US dollars is at XYZ. I'm going to convert how much money I have on my Jamaican credit card. And when I convert it and I get 500 US dollars, I know say I am going to have a running balance in my headspace that we can't pass $500 once me use the credit card. So the first shop my shop is $195.95. You're going to run it up to 200 because you know what the credit card companies also do? Give you a little leeway so you can go overdraft. And once you go overdraft, you pay them more money. It's just a trick with the credit card companies. So it is always nicer when you can round up. So it's $195.95, round it up to $200. So you know you have $300 left. So just keep that running balance in your headspace. It's the same thing here with this match. The x is not equal to 3, but for the calculations method, you are going to assume that x is equal to 3. You know what is happening? When a Blackanese in foreign see you are swiping your credit card, they don't even know that it's a Jamaican credit card. As far as them say, you may live there because a whole heap of Jamaicans them live there, and you back out a credit card, them say, oh yeah, I got a credit card. Them say, but the credit card is different, but don't worry about it. There are so many different, all of the stores in a foreign can't issue credit card. Ross is a credit card, Macy's is a credit card, TJ Maxx is a credit card, so it don't matter nothing as long as you can swipe. Some man look on you and say, oh, him paying $195.95. Lie. You end up paying more because you're using your own local currency. At the same something with a question here. Even though we put it in 3, we are set in our headspace that it is not 3, it is only approaching 3, because we're using the calculations method. So look at what happens here now. So it's going to be 2 times 3. That one here is not exactly 3 now. It is only approaching 3 because we're using the calculations method. Work with me and you know pass the course. Just try to understand what I'm going on. If you now understand, stop me and say, sir, not following. And then I'm going to have my plus 5. And 2 times 3 is going to be equal to 6, and 6 plus 5 is going to be equal to 11. We knew this one before. So the point I'm making is when you're doing your question and they say to you, use the intuitive approach. If them say to use the intuitive approach, you know what the answer is supposed to be because you can't work it otherwise. Just word the intuitive approach and you know what your answer is supposed to be and just give them on paper and you're good to go. You will hear me say this again when I move into from the same limit here into first principles differentiation. The man they may say to you, differentiate, rate using first principles. The moment you use another method other than first principles, you are wrong. Not even 1 mark you're going to get because it didn't follow the instruction. However, you can use another method in your headspace to double check your answer to make sure the way your answer you get is right. Because you know the funny thing about calculus 1, more than 50% of the questions that you are going to be doing, you can double check your answer. You have many ways you can double check your answer to know that you're right. So I keep saying you shouldn't come out of calculus 1 exam and not sure if you pass the course. Once it is that you're diligent. All right. So my question to you, and especially for those who weren't here last class, but for everybody though, was this difficult? Are you understanding? Is there something that you're not getting that you want me to explain or re-explain? Honesty.
Sir, for me, my first mistake was to put 3 where x is. And I did the calculation there and got different figures, but I corrected myself and got the right.
Oh, so what you did the calculations approach first.
No, I did like 2.9 times 3 plus 5.
Oh, okay,
Yeah.
got you. And I know, Sash, I like your honesty. Can I tell you a secret, Stash? I know you're alone with here. Somebody's in the class with, but them no want to talk.
Sir, I don't me do, you know. I am at
Wait,
times I raise it to a power. So a power is me I calculate with. So two raised to 3.1, 3.01, and that means.
All right. I love your honesty. And you see the thing about it? Let me tell you why it is important for you to share with the classmates, because sometimes you're just learning the topic and you will make mistakes. And this is when the mistakes ought to be made. So this is why I want to hear those mistakes. So make the mistake, all of the mistakes, they make them know in the class, you know. So that when you reach the test now, exam, you'd have passed those stages of making those mistakes. Yeah. But I'm gonna say to you though, was that Ryan a while ago who said that you raised something?
Yes, sir.
All right. So Ryan, so remember now, the function that was given was 2x plus 5. There was no power in there. So you have to just be careful and look at the function. And you notice I changed the function this time around. The last time, look at the function the last time around.
The last x minus.
Right. So I didn't even put anything, you know, x minus this time because I don't want you to think that the function, why is this not going up? I don't want to think that the function is going to remain the same all the time. The function will change, right? So just be careful of the function. One other advice I'll make to you is that when you see the question on the screen and you write it down, just look back to make sure that you write on the correct question. Because sometimes you are doing a question and you're doing the question right, but another question will mean you do your question where you write off. Because of two different something you write off. So just be careful of how you're writing off. And as I said before, Ryan, I don't feel no way about that. I'm happy that the mistakes are being made now, and I love the honesty. All right? Okay.
All right,
so, bless up.
Before we move on, the first part, you can just go over the intuitive approach part. I never really, because I joined late, I never really catch that part there.
All right, no problem, next time. So what I'm saying for the intuitive approach, let me just, all right, this computer wants me to synchronize and another. All right, so for the intuitive approach, all right, let me go to this one. For the intuitive approach, we're given a question, the limit as x tends to 2 of x minus 1. The intuitive approach is that you are looking at things incrementally. You are looking at things incrementally. You don't know what it is. You are investigating. All right. We looked at an example in class on Tuesday to say somebody got kidnapped at point A, and the residents or police converging to point A where the person was last seen. You don't know exactly where because, I mean, somebody called and said, no, man, upon Knoxwood Boulevard or upon Mountain View Avenue, how long Mountain View Avenue be, right? But what the man is going to do now is to look at the different tributaries on Mountain View. Them going to go J. Road and Langston and Arthur Winton, you know, all of the little cut off them so them can converge and try to inch up and inch up and inch up until they get close until them can corner the person. That's exactly what it is that we're doing. Now remember, and I want you to look at the first example here. Look at this. My first intuition, remember we're talking about the intuitive approach, you know. My first intuition is going to be far from my answer. 0.9 is far from 1. Believe it or not, 0.9 is far from 1. Is 0.9999 closer to 1 than 0.9?
Yes, sir.
Come on. So the first one is going to be a little bit offish, but as I do my investigation, my intuition, and as I do my intuition, it gets closer and closer and closer and closer. Now, hear me out. There is one very good student in the class that I had for a foundation course, and I said to the student, I said to the class, if I catch you for business calculus or calculus 1, there are some things that you are going to get. It's going to come back to haunt you. So let me just stop right here and say to you, whoever will be teaching you calculus, you see the same inching, something that teacher talking to you about now? You inch from 1.9 to 1.99, and you inch up to 1.999, and you inch up further to 0.9999. You're going to have plenty more inching to do when you're looking at the application of differentiation and the application of integration for calculus 2.
The same concept. So again, beg you know, try get this concept now so that when we reach calculus 2, or not when we reach, when you reach calculus 2, you can make sure say this thing is already cemented in your headspace. All right? The engine is going to be very important. And look at it. And also the point that I just made, that your first intuition is not going to be close to your answer. The first intuition is not going to be close to your answer. But as you inch and you make other intuitive guesses, what is going to happen is that you're going to get closer and closer and closer to your answer. Because and deliberately, this one I go, let's start. I did 1, 2, 3, 4, 1, 2, 3, 4. This one I purposefully did 1, 2, 3 because I don't want anybody to think that I have to do 1, 2, 3, 4, 1, 2, 3. Matter of fact, what I also did next on when I asked for the answer and I got 10.8. And then I asked for this one, I got 10.98. And I said, okay, I can guess. This is going to be 10.998. And if I had done 2.99999, I'd have gotten 10.9998. So each time I'm doing this, I am inching closer and closer and closer and closer and closer to my 11. So I can say, hey, what the heck? This left-hand side moves to 11. This left-hand side moves to 11. I'm doing the same thing. I'm looking at a number that is close to 3. So I'm going to say 3.1. 3.1 is the closest because if I say 3.5 or 3.9, that's 4. So 3.1 is the closest. But I am going to go even closer. 3.01 and even closer. 3.001. Then sorry, they stop right there. So thank you for asking. We could have go further. No? We could have said 3.0001. And if I had said 3.0001, what would have been my answer? Unmute an answer.
$11.0002.
Very good. 11.0002. So put it this way. The studying of mathematics is a pattern, and you have to be looking for this pattern. There are several areas in math that you're in between. This is one such area that you see a particular pattern. Once you can identify the pattern, good to go. Good to go. All right. Now, I don't want anybody to think that this man coming with them easy something here and even no say we say bright. I'm coming them like a fool something in a class and things that we not understand. I'm just here to say to you that it's not always black and white here. Sometimes we can have shades of gray that we have to know, understand what these shades of gray mean. So let me give you a gray. Then, sir, you know, but I don't like with some teachers, them start with the easy something in a class, you know, sir. And then after that, now them left if you do the hard something, sir. Why I don't know, so wicked. It's not a matter of being wicked. What it does is, I used to say the same thing about my teachers, but what it does is the teachers now trying to see how best you can use a given bit of information and translate it now into another level. So if I want to see how many of you, by the way, Lexton, you asked the question.
Yes, sir.
You're getting no pops, right?
Yeah, man, we get the intuitive.
Good job. All right. So this one here, matter of fact, let me ask you straight up. Using the calculations method, what is this answer?
1.5.
If I clap you today, see? If I clap you today, Jesus Christ. Look at it again and tell me.
3, sir.
So,
Like hear me, you know. Okay.
All right. So okay. So you can agree with me now that is not 1.5.
I agree, sir.
Okay, and tell me why.
Sir, I count, me can't count.
You know, I'm happy that you said it and not me, But yet, so this is the point that teacher is making. So you see what I'm doing here, because I didn't have to tell you the calculation method. I could make you sit on and get bored doing the intuitive approach, and but I'm saying to myself, to make this thing go a little quicker and nicer, smoother, I'm gonna do two birds with one stone. So I'm teaching you both methods at the same time. So guess what? So if the man them said to you use the intuitive approach, you say, okay, fine, intuitive approach. Let me just calculate this. And but a matter of fact, I bet you Ryan never write down one something. Ryan, did you write down anything at all?
Oh, sir.
No, man. Ryan just say 2 plus 1 are 3. 2 minus 1 are 1. 3 over 1 are not 3. 3, sir. Because this thing can be done into your headspace. And which is what I'm saying. You can, most of what it is that we're going to be doing, you can double check your answer without even writing nothing down. So no, I know that this limit exists because I got an answer using my calculations approach. So going from my left-hand side, it must approach what limit?
3.
Yeah, man. And from my right-hand side, which limit again?
3.
All right, good. Do me a flavor. I'm going to start it, because what I want to do is to see how best you are manipulating. What I've just given you is a rational function. What rational means? It's rational comes from the word ratio. ratio is ratio, but rational is rational. So ratio comes from the word rational. And when we talk about ratio, you buy a personal pizza or a personal pan pizza, and you get 4 slices. It's a ratio. So you give me one of the slices, and you eat 3 of the slices. So if I ask you, what is the ratio of the slice from Mr. Shan to Kelvita? She can say, a 1 to 3 ratio, sir, because I gave you 1 and I had 3. So the 1 to 3 ratio can be converted to 1 over 3. So you can say that sir got, whatever the situation is. It's going to be, the whole fraction is going to be a quarter, because there are 4 parts to serve in the first place. So I'm just saying to you, the point I'm making is, once you see a fraction, you're talking about sharing. It's a ratio. So my aim for tonight now is to see how well you can manipulate putting something in the numerator 1 upon top, and then something with the denominator, and the denominator is with the bottom. All right? I am going to press pause, and I'm going to see how well you know what the answer is. I'll just show you how to cheat the system, to double check your answer, to work towards it. So you know that the answer is equal to 3. Look how I'm going to know. I'm going to put equal 3. You know it's a 3. Use the intuitive approach for me, please. And then I'm going to do one other question on the intuitive approach, and then move into another method of limits. Start for me.
Sir, can you scroll up, please?
You stepped away for a bit. Oh, never mind.
No, you're right. I stepped away, but I'm using a wireless headset. So I can hear what is happening as I go. So even though I'm not with you, I still can hear you. This up you're talking about or the other up?
Yes, sir, that's correct.
All right, cool.
So straight to the top.
All right, I apologize. I don't know why it's not. Let me see if I can undo the. I had linked the pages. Let me see if this is the problem. Yep, that was the problem. All right.
Thank you.
Problem. All right. Honesty. I don't want anybody to sit in my class and feel frustrated. Is there anybody that is struggling that needs some help?
Letters them are going good, sir.
Very nice. I'm very encouraged. Love it.
Sir, scroll down to the next part, please. Sir, sorry about the trouble. Can you go down again? Scroll down.
Excuse me, sir.
Yes, please.
I have a question. In terms of exams, sir, and you give us a question like this one. Suppose I don't get 11 as the answer, but I get that the limit exists. Would I get half mark or something? I got everything wrong. You not get half mark?
All right. So a question like this one here would be like a multiple choice. It is too easy a question to give you as a essay type question.
Okay.
I am developing the essay type questions to give you. And I mean, I can show you a question that I can give you for 2 marks, which is what I'm going to be moving into next. I just want to do this one here, and then I'll show you how, we do this stuff. All right. So this is what is going to be important for me now. All of you are responsible enough. I need for you to go and search past papers. Search for past papers. Go to the library, online library, search for past papers. Post the past papers in the group. I will pick up those past papers once I see them in the group. I will start working the solutions. Now, hear what used to happen to me when I was going to school. I was overexcited. So as I go to first class, we used to run, go to the library, go buy one past paper, and then look through the past paper and got very discouraged. I don't want that to happen to you. When you're looking at the past, because I was trying to see if I can answer all of the questions then, but of course, it was the first class I went to. So you're going to get the past papers. You're going to just post the past papers in the group. Oh, sir, I find this here. You just post it in the group. You leave them alone there. Or if one person wants to find them and do one posting, so they're all together in one thing, I have no problem with that. When I would have reached a certain part in the syllabus now, I would say, let us work the past paper questions on, and then we're just going to, one of the classes will come, is just peer past paper running. You hear me out? You see, in this pandemic, past papers are very useful here. I'm not going to say nothing more. Past papers are very useful. In our outside of the pandemic, working past papers are always good tips in doing an exam. So please get them, share them, and we can work them together. All right. I know some of you are still working, but how we stay?
Finish.
Finish also.
Yeah, finish too, sir.
Nice. And you got it free?
Yes, sir.
Yes, sir.
What? Anybody in the class work downtown?
Like downtown, sir.
You're in the wholesale them.
No, sir.
Right. You're lost. I was just gonna ask someone to buy a bag of tigers so we can share up in the class. And I go on with things, man.
Sir, we have somebody that sells tigers in the class, sir.
And then the ends to here, sir.
But don't buy our peanuts, sir.
Yes, sir. Don't buy the peanut.
Oh, goodness. All right, never mind. I don't think Ends would want to carry a bag of tigers to your office. They will take it and beat you with it. Oh boy, I tell you. All right, let's go. I'm very pleased. I'm very proud. Seeing 14 of you on Edico, plus the one with the bus left, plus the two were joined. So that's 15, that's 16, 17 of you. Okay. 17, no man, when I have 17? Oh, I'm logged in twice. 18, 19. Okay, yeah, so there are 17 of you.
Sir, oh, you sound like you couldn't count it while ago, sir.
No, because I'm seeing 19 participants. I'm wondering, because I know I have 14 on the platform. The boss leave one, so that's 15. And then I see two new ones that are 17. But we see 19, I'm going to say, oh, that's a me, because me log in 2 times. All right, so we are all together. Very nice. Now, I'm going to work this because I'm very excited to move into some other areas. So, and guys, please, I don't want none of you to sit in my class and say, nobody want to ask you because everybody understand and I get the answer. And me not get the answer, so me know nobody say me done. Right? You are dunce when you sit in class and don't understand and say nothing. That's a dunce behavior. You stop me here. You not care when nobody wants to say. Stop me and say, sir, hold on, press pause, or you get it. It is your responsibility to say to me, sir, I'm not following. And I don't want any of you to feel ashamed to say that you can't do it. Come on, let's go. So now we have a rational function to find the limit of this rational function. Not a problem. We're using an intuitive approach, not a problem. So let me just take off this spotlight because it is too bright.
Sir, check the chat, please.
Okay, we'll do. Oh, you know what happened now? It's because I did this for this student. That coming there. Okay, back up now so I can. Can I reduce the size of this thing? I'm checking. Okay. All right, no problem. All right. Okay, German, I saw yours too. Sean Anderson. All right, no problem. All right, so I'm seeing your messages. Those of you who are not following me, just stay with me. I'm not going to leave you. Just stay with me. It is important that you stay with me and okay. Just stay with me and you'll be, but you know, watch me first and then you can see if you can get it. Watch me now. Put on the piece of chicken leg and let us go. Ready? We are evaluating the limit. We're evaluating the limit as x tends to 2 of x plus 1 over x minus 1. And we're using the intuitive approach. So them really give intuitive approach on the exam. The truth is, I am yet to see them give you one of those questions, but it's a very good teaching ground for you to understand the whole concept of limit. They can, but I'm yet to see them do that. Let's go. From the left-hand side, I'm going to have 1.9. Sir, why 1.9? Because I'm approaching 2. Watch me. For those of you who just joined, so 2 right here, so. Over here, so we'll call the left-hand side. Over here, we'll call the right-hand side. Sir, how you know? Why never call it the other way around? All right. So look on the screen. On the screen where you look on right now, your right hand upon the side there, so. Talk truth. And your left hand upon the side right there, so. All right? So that's why we call it the left-hand side, because when you look at the screen, that's where your left side is. Don't turn around and tell me, sir, the other side is the right-hand side. No. All right? So why we call it the left-hand side? Because when you're facing the screen, your left side is on that side. And then your right-hand side is on the other side. So moving from the left-hand side, I'm approaching 2. So me I walk and I walk and I walk and I walk to approach 2. So it means that I'm going to start at 1.9. But I can get closer by saying 1.99. Get closer, 1.999. Still closer, 1.9999. Still closer, 1.99999. So let us investigate. 1.9 plus 1 over 1.9 minus 1 equals how much?
Sir, that's 2.9 over 0.9, which is equal to 3.2.
3.2. Very good. That's what I was looking for, the decimal. 3.2. All right.
Sir, before
So
you
all
proceed, do that over, please. Repeat what
so
you just said.
all right, so let me show you. I'm not going to take anything for granted. So let me show you. I'm going to call this side work. Calling that side work. And I'm just going to do one example, and you can see what it is that we're doing. All right? So I'm doing 1.9 plus 1 over 1.9 minus 1. What are you doing, sir? This is my function. Anywhere in the function I see x, I'm going to be putting these numbers in them and work it out. So because we're at the 1.9, it's going to be 1.9 right here. So sorry, let me go back to my spotlight so that you can follow what it is that I'm doing. So anywhere in the function I see x is what I'm going to put these numbers in. So this is x, so this is going to become 1.9 plus 1 over 1.9 minus 1. See here, so 1.9 plus 1 over 1.9 minus 1. 1.9 plus 1 is going to be equal to 2.9. And 1.9 minus 1 is going to be 0.9. And when you do all of that noise, that's when you get the 3.2. Everybody see that?
Yes, sir.
Yes, sir.
Nice, nice. So now, tell me, 1.99 plus 1 over 1.99 minus 1 equals?
3.02.
3.02.
All right. Then this one works out to be?
3.002.
3.002.
Very good. Because I cannot see something now in the 3.002. I might be wrong, but I just didn't write it, not less. All right, 3.002. Right, so I have the same number of decimal places. So in this one, I have 1 decimal place because I have 1 decimal place here. I have 2 decimal places here. I have 2 decimal places here. 3 decimal places. 3, 4, 4, 5, 5.
Sir, you're extremely low.
You serious? Like seriously?
Yes, sir. Sir, me I struggle for hear you, sir.
All right, here the plus. Oh, so I have 2 headsets. One wired, one wireless. Last week I was using the wired one, and you say you weren't hearing me from it. And then you were hearing me better on the wireless one. So I'm using the wireless one. So what I'm going to do is try the wired one. So maybe I have to alternate the headset.
Sir, I have a question.
Yeah. Are you tell me, well, can you hear me before you ask a question?
Yeah,
Yes,
I'm
sir.
hearing you
Yes,
now.
sir.
Nice
Much
and
better?
dear.
Low,
Far
whoa.
better, sir. Far better.
Yes, sir.
All right,
Sir, why
good.
are you shouting at us?
I'm sorry. I got you with a question.
Um, do they usually tell you how much guests to make, or you decide that?
You decide that.
Okay.
You decide that, and once it is that you can see what is happening, you stop. So right here for the left hand side, you can see that this is tending to what number? Say 3. See it, no?
3.
Right.
3.
Yeah, man. So when you catch 3 now, you can't stop. Matter of fact, I didn't even have to go through the 4th decimal place and the 5th decimal place because I catch 3 long time. All right. So for those of you who just join in, please, and while I write, I'm going to say to you, I understand. I know I got a message or two today about, joining class a little late-ish. One of the things I'll say to you is that every night I come class, don't feel say is not teaching going on. So you can miss a whole heap of something. So I'm going to encourage you to always try to be here, just to get the stuff. But I can understand we will have incidents where we can't make it to class, right? I got one today, but we are fine, and person is here, so we're good to go. Let's go.
Sir,
Yes,
another
honey. Go ahead.
question, sir.
Mhm.
That side workout that is showed at the bottom, we need to
Mhm.
show that.
No, that's a little school maths,
Okay.
a big school with
Really?
calculus with yeah.
But just a checking, sir, because I realized that this is the only time it actually showed that. So I'm just ensuring
Right.
not
So
thinking that I missed it.
I only fair enough. I only did the side work because I know they have two new students and they didn't see the stuff. So you are correct. I didn't do this, or maybe I didn't do this really for the last time around. But because I have the two new students, I'm actually showing them, showing the class how it is that we got what it is that we did. But no man, a big school with it, no man. All right, right hand side. So watch me now. So we're moving. I use you this time. We're moving here. So from the right hand side, we're going, we're approaching 2. So from the right hand side, we're going to say 2.1, 2.1. Then we can go to 2.01. Then we're going to go 2.001, and then 2.0001, 2.00001. Sir, I'm not going to more. You don't have to. You don't have to. So what we're doing is the same function like this. Anywhere in the function you see x, you are going to be putting 2.1. You evaluate that, you write down your answer. Then you move on to the 2.01, so forth and so on. So work with me. 2.1 plus 1 over 2.1 minus 1 equals how much?
2.8 or 8.
2.8. All right, fair enough. Next one.
2.98.
2.98.
And then this is 2.998, don't? Somebody say yes.
Yes, sir.
Yes, sir. Second one, sir.
Say it again, hon.
I never went past the second one.
All right. So it's 2.998. All right. So right there and then you show them that so you knew from beforehand, because sir used the algebraic approach, the calculation method, to show you, say, boy, say x is not equals to 3, x is not equals to 3, but you're just going to allow x to be equals to 3 just to do a quick check to see what is happening. I know that it worked out to be 3. All right. So this is what is happening. And that's what really happens. That's what really happens. All right. Let me see if I have. All right. So let me just walk you through. Let me just walk you through something. I'm going to do a new share, and I'm going to walk you through something for those of you who are not following fully. So we're looking at the intuitive approach. So here goes a new question. Here goes a new question. And what this new question says is, you're finding the limit. Let me bigify it. All right. It's now bigified. So we have a limit as x tends to 1 of x plus 1. We're looking from the left-hand side. We're also looking from the right-hand side. Remember, when you're looking at the intuitive approach, we have to look at both sides, all right? So from the left-hand side, I can say 0.9, then 0.99, 0.999, 0.9999. Anywhere in the function, so these guesses, 0.9, 0.99, and so forth and so on, now will represent my unknown values, my x values. So anywhere in the function I see x, these are the numbers I'm going to put in to get these numbers. I'm going to use a term. These are my independent variables or my x values. Your x values are your independent variables, and these are going to be my dependent variables or my y values, my output. So this is your input, this is my output. So my input are my independent variables, my output are my y values. So I put in this, I get out that. So the first one put in, the last one take out. All right, watch me now. 0.9, 0.9 plus 1 is 1.9. 0.99, 0.99 plus 1 is 1.99. See it here? 0.999 plus 1 is 1.999. So it is really not difficult. Really not difficult. And then now we can say, you know what? All me have to do, is add 0.0001, and that's something you turn 2. That's all my. What is 0.0001? One little bit of something. So I can say that this thing turns to 2. All right, sir. I'm going to check to see what happened now to the right hand side of the function. It sets to 1 for the right hand side, 1.1, then 1.01, 1.001, 1.0001. These are my input values. So anywhere in the function I see x, add them something you're going to put in. 1.1 plus 1 is 2.1. 1.01 plus, at the same, something over here we are talking about, 1.01 plus 1 is 2.01. This 1.001, I put in something here, add it to the 1, 2.001. You say, oh, but sir, 2.00, that one is so far off, that boy, we can't drop it off and now we get 2, sir. And then we now say that it is of a good behavior since the limit approach is true from the left and from the right. So when I look at the left-hand side and I look at the right-hand side, the limit is approaching to the same number. How good behaving people that man. You don't have to worry about you. All right. So this is how it is that we do the intuitive approach for our limits. Now, let us look at the calculations method. We are saying that it approaches 2. Let us look at the calculations method. Remember, x is not equals to 1. But for the calculations approach, I am going to only assume that it's equals to 1. 1 plus 1 equal?
2.
2.
2. And that's how we get the stuff here. So we know the answer there. And this is the absolute, well, that's the one I just gave you a while ago. And then now, maybe I'll go into that one here. Maybe I'll go into that one here. Maybe I'll go into that one here.
Sir, not 3 is supposed to be right there, so. In the sentence, sir, in the sentence.
Here, I just put that there to see if you were paying attention. Very nice. So you're going to get the first bag of tickets. Who this?
Charlene, sir.
Miss Crum, are you that?
Yes, sir.
Somebody just said something about wife a while ago?
Ryan, sir.
Make him say, man. Him no say Jeremy in the boat. All right, so let's go. Don't follow me. Don't follow me.
Don't do that. Me that drink water.
It's all right. The reason, let me confess, the only reason I did it because she kind of roughed him up in the WhatsApp group, and I said, thank you, Charlene, because the boy really took on for true. Charlene, don't follow your teacher here. Teacher don't mean nothing.
Sir, that is how I always treat him, sir.
Okay, yeah, man. In Tobanisi, jeez. All right,
yes,
let's go.
they're very.
All right. All right. So, but he's a nice student, though. All right. If you look at this one, yeah, you're right. So this is 3. So you know what sir did do when sir was reading a question, come they want type of something. We just copy and paste, yeah. So them things that catch me too. All right, let's go. Can anybody read this down here? So come here, please. X tends to what?
Infinity.
Very good. X tends to infinity. All right. No. Oh boy. Look how me going to flop somebody in a class tonight. In doing this question, I want somebody to give me, in this particular question, an infinitely large number. You don't have to be afraid. Not because I said we're going to flop somebody tonight, but just give me an infinitely large number. Anybody, somebody, and if nobody answers, I'm going to call upon somebody.
1 million.
All right. You know, Ryan, you know, I knew somebody was going to say 1 million. I knew somebody was going to say 1 million. And, you know, I'm not going to flop you because 1 million is a infinitely large number. But guess what? It's in a question like this.
Yes, sir.
10.
Sir, what
10.
to one?
One could have worked, and then after that, we'll work itself up, you know. But guess what? In this particular case, I can say 10 is an infinitely large number. All right, do me a flavor. Do me a flavor. Ha ha ha. Ha ha ha. Ha ha ha. I want you to look at that question for me. I'm going to give you 5 minutes, 5 undisturbed minutes, 5 undisturbed minutes to look at that question and tell me if, well, not tell me, work that question out for me, please. Work that question out for me. Work that question out for me. No. I give you 5 minutes. On a mark, get set, go. I am going to mute. Go, go, go.
So which method?
Intuitive. Intuitive.
Sir, is this question a trick?
No, it's not. It really isn't a trick. No.
Sir, may I have a number now? Our answer. Can I message you privately?
No, man, tell me the answer you get.
2, sir.
What?
You get 2?
Yes, sir.
I get 2 too.
That me get 10, sir. Me just assume say infinite at 10. As you said, me don't know if it's right.
All right, so I am doing this question in my head and I'm not getting 2. All right, what I would say to you is, all right, so if you're looking at the question and you are doing, no, I don't want to give any hint. Just look back at it again. I am not getting 2. I'm getting a different number. Take another 2 minutes or so and look back at it. I will do the question with you now. Don't think that I'm leaving you to sing. I'll do the question with you, but take another 2 minutes and take a different approach. All I'm saying to you is, let me just explain what I was talking to you about with the 10. You see, for the ease of calculation here, if you get a question like this, I wouldn't want you to go write down 1 million divided by 1 million. All right, put it this way. Try this for me.
So if I use the other method, the calculation method, same 2 I come up with, and I did the long way first.
You come up with the same 2?
Yes, sir.
All right, watch me. Watch me.
Answer. What's the answer?
What the answer?
Sir, I'm change the number and I told me get.
All right, then. Okay, fair enough. It may be 2. All right, let's go. Do me a favor, though.
Change my answer. One time I get 2. When I use 1, I get 1 answer, 0.25. When I use 10, I get 2. But when I use 100, I get 1.5.
Ah, because that's exactly where I was going to go. Remember, when you're using the intuitive approach, you can't just use one number. You have to go up and you have to investigate. So if you're using 10, what? Okay, so the question now is on infinity. And if you're using 10 and 10 don't work, try 100. So the person who said they try 100, that's very good. And when you try 100, try 1,000. The point I'm making is 10 could be an infinitely large number. Put it this way, a madman on the New York street, if you give him $10, that's a lot of money for him. Because $10, well, I don't know about now, because we've been in trouble for a couple of years now for the pandemic. But $10 can buy you enough food to go cook with about 2 days. All right? So try 10. When you try 10, you got 2, because 10 over 10 minus 5 is 10 over 5, which is 2. When you try 100, what you get?
1.05.
1.05? All right. So let me continue with this conversation. Remember I said to you, class, that your first initial guess, is that a good guess?
Sir, the limit going
No.
to be 0, don't it?
I don't understand this.
Your
Oh,
first
no.
guess is a good guess, but there's always a closer guess than your first one.
Very good. Excellent. So there's always going to be a guess closer as you go along. So when you do your first guess, you're getting the limit to be 2. But when you look at another infinitely large number, say 100, you're getting the limit to be 1.05.
Oh.
So it can be 2. So now that you use 100, why not try 1,000 and see what the limit comes out to be? And after try the 1,000, why not try 10,000? And then 100,000.
Sorry, you're not answering me,
Sorry, say it again, sweetie. Sorry.
Is the limit 0?
Limit 0? Where you get 0 from?
Answer is 0. Sir, it's inching closer and closer to 0, so
But
Or
let me not
negative.
answer you. No, hold on. I'm not going to answer you. You are going to tell me if it's inching closer and closer to 0. I am not answering you. I want you to do, what I want you to do is to be investigating. Because remember, I told you that I did the answer in my headspace and we're investigating. So you are going to let me, you will tell me whether or not it is in fact getting closer and closer to 0. So this is what I want you to write for me in the books. 10, I'm going to do the evaluation for 10. I'm going to get 10 to go into 2. Then again, write 100 because you're investigating the infinitely large number. 100, then you get to 1.05. Then again, do the 1,000 and write down what you get. Then again, do 10,000, write down what you get. Then again, do 100,000. You don't need to reach 1,000,000.
Oh, 5 at the limit.
What is the limit?
5.
5.
Sir, that me keep on I get when I go up.
Sir, the limit is 1.
No.
Sure, I get 2
And that
and
may
I get
say no.
1.0.
I may get 1.005.
All right. Somebody try this for me. 10,000 divided by 10,000 minus 5 and tell me what you get.
5, sir.
What if you get 5?
10,000.
Sir, repeat that.
10,000 divided by 10,000 minus 5. You can't get 5.
Get -4. No lie. Yeah, wait. Hold
Yeah,
on.
-4, sir.
-4, sir.
I got -4.
So 1.0 something again, sir. 1.00 something.
It's supposed to be -1, a negative quarter.
I got the minus first.
By 10,000, yes, sir, divide by
10,000 minus 5.
5.
9,999.
All right. So hold on.
I'm getting 1, sir.
No, you see,
1.0 something together.
Yeah.
all right. I hear you, Jermaine, and I hear you, Ryan. But you see, where I want to get you is, and I don't want anybody to think that I am showing them up. But I want you to, is when you're given an answer, I want you to be able to interpret that answer that you get. So somebody said to me, -4, sir, or -5, something like that. How can we get a negative value when the numerator is 10,000 and the denominator is going to be 10,000 minus 5? That means we have a positive number in the denominator. So when you divide the numerator, which is positive, by a positive denominator, there is no way you can get a negative number. Talk truth.
Mm-hmm.
Anybody see that?
Sir, it depends on whether you subtract or divide first.
What?
No, seriously, sir, because you can, what I was doing, which is why I was getting a negative number, is I was canceling them.
Canceling what?
So 10,000 into 10,000 give you 1. So at the top you have 1 and then you have 1 minus 5 at the bottom.
No, that's
what I'm
illegal.
saying. It depends on the method you use.
No,
So that's
but
why.
Unique, that method is illegal. The popo will come for you. Unique, BOMDAS, brackets of multiplication and division before addition and subtraction. There's no way you
So,
can
sir,
cancel.
question. Is it that you put the 10,000, you put 1 over the 10,000 divided by the 10,000 minus 5? And that's how you get the negative?
Write for me, please. Write 10,000 and then draw one line, your division line. And then you're going to write 10,000 again minus 5. And then now, you see that 10,000 in the numerator? You can't cancel it with the 10,000 at the denominator because the 10,000 in the denominator is married to the -5. Or you want to go take the man wife or the woman husband. You can't do that.
Poor sir.
You can't do that. So you have to go work out the 10,000 minus 5 first. And then where you get left now, you have to wait until them broke up before you can move in. So what's going to happen now is that you're going to have the 10,000 divided by 900 and rate 80. So that means you have to get a positive number.
Sir.
That makes sense. Yeah.
In my investigation, every time I go up in the ranks. So I did 10 first, I got 2. And then I did 100, I got 1.05. I did 1,000, I got 1.005.
Very good.
I did 10,000 and I got 1.005. Therefore, I am intuiting that is 1.
Duh. The limit tends to 1.
Sorry, I'm not calculate how long and it's a 1 how long.
No, but guess what, Nesta? No, but guess what? You see, when somebody tell me, and this is one of the things you can learn from me, is when me hear the right answer one time, because I heard somebody say 1, but I ain't not gonna respond to it. You know why? If me say 1, everybody in the class done, and I'm gonna say, oh, them get 1. I want other people to start doing them own calculation because there is something now that I have to go stop the class to go deal with. Because I'm hearing some illegal stuff where the poor will get involved in. All right, give me a few. I'm coming back to you. All right. So there what the a case in students, which is why it's important for you to speak to me in class, is that so even if I wanted to move on, there are some things that I must do. There are some things that I must do. So that limit, when x is 10, the function, let me just do it. Can I just copy here? Oh crap. All right. Copy. No. So when it's 10, it's going to be this is going to be a teachable moment. Don't worry about that dark stuff that you're seeing there. I'm just using a software to type as I go along. So fret not. So when it's 10, it's going to be equal to 10 over that. And then you're going to say that is going to be equal to 2. And I agree. When it's copy, paste. When it's equals to 100, it's going to be 100, which is really 100 over 95. And 100 over 95 is going to be, what value to me again, please? Oh, sorry. Look here, guys. So this is a teachable moment. And I want to look here. You cannot say this 10 cancels in this 10 and goes one time, and then 1 minus 5 is 4. That is illegal. 1 minus 5 is negative 4. That is illegal. And that error should not be made ever, ever, ever again. This 10 is a standalone in the numerator, and this 10 minus 5 is married together in the denominator. So we'll have to combine these two first before this 10 can take part. That 10 you can't want, that 10 here, you have to wait until the 5 use the 10 and then him get the what left. So it has to be 10 over, and that's why you got 2 right here, you know, because this 5 had to work with this 10 to say 10 minus 5 is 2. Sorry, 10 minus 5 is 5. And then this 10 into 5 goes 2 times. 100 cannot be cancelled with 100. It has to be, you have to work this 100 with the negative 5 first. So you're going to end up with 100 over 95. And tell me the answer, please. 100 divided by 95 equals what?
105.
1.05. All right. And similarly, let me just do this for ease. Copy. And I go here, bam, 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 and I paste, and I delete you. And then I'm going to go to 1,000. I'm going to 1,000. And 1,000. And don't feel that I feel in a way because the mistake is made, you know. I tell you all the mistakes here. So when you do this calculation, again, let me just say it one more time. This 1,000 cannot be cancelled with this 1,000 because this 1,000 must see if this marriage can work between the negative 5. If not, then it just move up to the 1,000, move with the 1,000. So it's going to be 1,000 divided by, and I have to do this operation first. All right. So it's going to be 1,000 divided by 1,000 minus 5, which is 995. So when I do this calculation, what do I get? 1.005?
Yeah.
Yes, sir.
Good job. And then now, paste. When I do this now as 10,000, I'm going to stop at 10,000. I'm going to stop at 10,000 because there's a point that I'm going to, well, I'm not going to make the point yet. I'm going to come back to this question, 10,000. I'm going to come back to this question. So I'm so happy that I have it typed because I'm coming back to this question sometime later. So 10,000, and similarly, this 10,000 can't cancel with this 10,000. That's illegal. Illegal. So illegal it is that we need to pray for forgiveness. you have to do this operation first down here, so, and then you combine the whole fraction. So that is going to give us now 1.0005. Talk through.
So, sir, me have a question now.
Go ahead.
How do you work this out with the intuitive approach?
This is the intuitive approach.
This is
really, sir?
Really, sir?
This is the intuitive approach. You know why? Because you're making guesses. Look here. You remember, see the intuitive approach, you know?
All right, sir. So how you approach this from the right side?
All right. So now, when you have, all right. And that's an excellent question. I know, and what it says to me is that you're learning, and I feel like a very proud teacher tonight. And guess what? I am not one who is going to rush through so that you don't understand. Let me combine these. I really want you guys to get this. And then, oh Lord, this is what, 1,000, so put it right here. So, all right, so I have the 10, 100, 1,000. All right, now. So this is from the, you know, what the heck? Let me just put example 3. No, let it stay. So, so what I'm looking at now, so you're right. So this is going to be the left-hand side, right? And you hear the question, then, sir, if this is the intuitive approach, you always talk about the left-hand side and the right-hand side, then tell me now, sir, how the right-hand side come in. Thank you for asking, copy. Thank you for asking, paste. So for the right-hand side, look at what is going to happen now.
Sir, I can get, take a guess before. You just also take a guess before you start, you know.
Sorry, what guess word again? Tell me the guess.
Sir, I was going to say put the negative since the right-hand side, left-hand side is positive, then the right-hand side would be negative.
Very
so it would
good.
be negative 10
and
negative
incidentally,
100.
And incidentally, and very good. And incidentally, the right-hand side is always positive and the left-hand side is always negative. So incidentally, you are correct. So remember, the right-hand side is always positive and the left-hand side is always negative. See, the right-hand side is positive. The right-hand side is going to be where you have the positive values generally, and the left-hand side is where you have the negative values generally. But yes, so in this case, very good. And that's what I like about teaching, when students can follow what is happening. Watch me now. So if the left-hand side is going to be negative of my infinity, all right? Work with me. This is going to be negative 10 over blowout, sir. But negative 10, sir, minus 5 is equals to how much? Negative 10 minus 5 equals how much, class?
Negative 15.
Very good. Excellent. So do me this now. Negative 10 divided by negative 15 equal how much?
0.6.
0.6. Positive or negative?
Positive.
Positive 0.6. All right. Work with me now, because this is getting interesting now. Copy.
Sir, what kind of schematic this year do?
All right, well, we'll see what's going on. We'll see what's going on. All right. And then now we're going to try this one. So we're doing the same thing, you know, but we're just going to put some negatives there now. So we have negative 100 over negative 100 minus 5. That means we have divide negative 100 divided by negative 105. And tell me what you get.
0.9, sir.
0. How much?
9.
95.
0.95. All right.
Yes, sir.
All right. And I want you to work with me, you know, because maths is a beautiful story to tell. Copy.
Oh, Jesus, I pray you speak with me.
No man, you're good, man. You're good. You're doing well so far, man. Just keep it up. All right. So we're looking to the left. So we're talking about the negative values of it now. So walk with me now. So negative 1,000 over negative 1,005. Negative 1,000 divided by negative 1,005. Tell me how much you get.
0.995.
0.995. 0.995. Okay. And no, don't do that. Sure.
Approaching one, sir.
Say it again, hon.
Approaching one.
Talk truth. And I will show you a nice little something, you know, for show you how you can find out where the answers go. All right. So this one, I can hazard a guess. I can hazard a guess because of the pattern that this is 0.99. One more 9, don't?
Yeah.
Yes,
all right.
sir.
Good. So watch me now. So from the right-hand side and from the left-hand side, you see that both of them are approaching 1. Both are approaching 1. So you know that the limit tends to 1. Now, as I said before, you may not see that this limit tends to 1 because I don't show you something yet. You notice that this one here, I just show you how to do the calculations method. So you could just go ahead and just substitute and then work it out and know, say you get 3 right here. So there's a method that I can do, because when people were saying to me, sir, the answer is 2, I said, no, man, hold on. And I did a question in my head and I said, no, the answer is 1. I will show you, right? I soon show you. I'm not going to show you just yet. I can't get out of the secret one time, right? So as for some practice now, we need to just look at the algebraic approach, right? We just need to look at the algebraic approach to get some practice. Now remember, let us look at this one. So I am finished with the intuitive approach. I'm finished with the intuitive approach. And the intuitive approach just now told me that when I look at the left and the right of it, I'm still going to end up with the limit approaching the same number. So I can say that this is of a good behavior. Budov Bath, copy. All of them is of a good behavior pace, and it changes 3 and say it tends to 1 from both left and right. Right?
Sure, that one you behave baddish.
No man, it behave good enough, but it's just what. And let me just repeat this part again. I think part of the problem is how it is that you're doing your computation. Now, hear me out. Calculus 1 is really not bad, but it takes into consideration a lot of your algebraic skills. Now, you see, those of you who have a problem with factorization, it will come up next year. So you need to go review your factorization. So the problem for this question, and I'm happy that I gave you, the problem for this question is that people are making a mistake to divide this 1,000 by this 1,000 and get 1 and say 1 minus 5 is equal to -4. Don't make that error ever again. And the same error was made right here. The same error was made whenever I did this one. The same error was made right here. All right. So we can't make that mistake ever again. And incidentally, when you do this calculation, if you follow suit with the same method, this would have canceled this to give you 1 minus 5. So all of them would have give -4 for the answer. And you know, so -4 could be the answer because the values would have changed, right? So that's what it is. For the calculations or the algebraic approach now.
Sir,
yes, please.
Can I give you an analogy for that?
Sure, go ahead.
Why if I forget our money before me?
No, talk truth. Yeah, man. Yeah, man. Real talk. Real talk. Yeah, man. So in this case here, I forgot work on them issues, you know. So you know, so sometimes some women want to move in and say, but him say him and she break up. Never you follow that here. Him tell you that because him have an ulterior motive. All right. So his ulterior motive is to get something. So he will tell you anything. Say, oh no, we are separated. Lie. As soon as him get him gone, and it works the other way around. She may say, oh no man, me and him mash up, man, right? Because she won't ride another. Geez, Charlene, you know, I was gonna say she has pretty clear eye, and I don't know. Oh, Charlene. I forgot to call her by a middle name, Charlene.
So you need to
No,
behave
sir.
yourself, sir.
I love my first name, sir. I don't like my middle name.
You don't like a big name because I was about to say Charlene, pretty car eye. You understand? But no, on a serious note, though, it does happen. So what we need to do is to work out individual terms first, and then when we work out individual terms, then we combine them together. There is no way I can take something from the numerator and then divide it into the denominator and then do a subtraction. That does not work. Hold on. All right, very nice, very nice. So let us look now at the calculations approach. And this one I'm going to run through pretty quickly because you know it. Sir, how you mean you know it? Yeah, man. Sir taught both of them together. Watch this. For the calculations approach, if I say to you, evaluate this here. Oh, x tends to 5. Sir say x is not equal to 5. But for the calculation or the algebraic approach, sir, we're to assume that x is 5. And then we're going to put 5 in other something. 5 plus 1 equal?
6.
And 5 squared equal?
25.
Easy 1, 2, 3. That done. Number 2. X equal 0. No, sir. We're going to assume x to be equal to 0. 0 squared is 0. 0 plus 5 is 5. And 0 minus 1 is -1. So we have 5 over -1, which is -5. Everybody see I get the -5 right here?
Yes,
sir.
Yes, sir.
All right, good. Nice.
Clear as
And then
mud.
no. Say that again, Jermaine?
Clear as mud.
All right, clear as mud. All right, cool. Now, look at this one here. It says a limit as x tends to -4. Watch me. -4 squares is 16, positive 16. And -4 minus -4 is going to be -8. 16 divided by -8 is -2. Me not spend no more time on this because it's like easy 1, 2, 3. All you do is just putting it in. And when you put it in, you will get out the answer. You put it in, you get out the answer. All you're doing is substituting. All you're doing is substituting. I promise you, it's not more than that. I'll catch you now at the point where I want to catch you. But before I move to the point that I want to catch you, I want to ask you a question. I hear Jermaine say that it's clear as mud, but does everyone understand the calculations approach? You just assume that, you just assume that the number there, that the limit is tending to, and you just substitute it into the function. The function is not static. Sir, what do you mean by static? It means that it stays the same. The function changes. So in this function, we have x plus 1 over x squared. Then the next function, we had x squared plus 5 over x minus 1. And the next function, we have x squared minus 4. All right, you know what? As a good little teacher, copy. Numero 4. I'm giving you a question to see if
the
you
first
really
answer. If you get the calculation approach, you have to work it right out, or you can just leave it at the like 6 over 25.
Yeah, leave it at 6 over 25. You know why? Me know a mistake when I do that. Yeah, leave it at 6 over 25. All right, look what I want to know. Number 4. That's how you're do now. Do that for me until we get.
We already have the answer.
No man, you just copy
-1,
something. This is -1. So this answer wrong, you know. Me just copy this from this a while ago and just change that. So now we put the correct answer.
0.6.
0.3.
0.3. Interesting.
There's 0.6.
All right. Ryan, what you say?
Wait, no. Sir, no care, give me a good time.
Yeah, we just ask Ryan.
0.6, sir.
Positive
0.6.
0.66.
Okay. All right. So Ryan.
0.6.
Okay. So
I
the
got
last
0.
three, the last 3 or 4 of you would have given me an answer that is closer because I want to know how people get 0.6.
Sir.
Mm-hmm.
I say.
No.
Every time I just sit it.
No, man. And that's why I say, you know, when you make other mistakes in class, no.
Sir, so you want it to like 2 or 3 decimal places?
Oh, would that be 0.7?
0.6.
So why nobody not telling me 2/3?
Sure, we're supposed to leave it as the fraction.
A fraction, sir.
Sir.
No, look on the one here. Somebody just asked a question a while ago. Sir, should we leave it as a 6/25? And I say, yeah. And then you're going to
negative 2 over negative 3.
Sure, man. Sure, man.
man. Sure. When I do the thing, man. Sure.
So I mean, still get it right then because I'm gonna do it.
Yeah, right. I mean, and if you say 0.66 or 0.67, if you said 0.67, I would give you enough marks. But if you say 0.6, we're not going to give you a mark. 0.6 is not the correct answer.
So you're stingy on the mark, then, man.
Mm-hmm. Them, man. Hey, a big school, you know. Big school. Calculus 1.
Sir, that means it's hard to get A. Your pen to write A.
No, man, it writes all A+2.
Really?
It's straight up. Yeah, man. I have students who get enough A. What? Yeah, man. Yeah, man. Watch this. So for those of you who are not following what is happening here, this -1, I'm going to assume that x is -1. -1 minus -1 is a -2, and -1 minus 2 is a -3. So -2 divided by -3 is a positive 2/3. When I multiply two negative numbers, I get a positive number. And when I divide two negative numbers, I get a positive number. Is that clear?
Yes, sir.
Yes, sir.
All right.
Sir,
yes,
before I move on, is it that the answer shouldn't be decimal?
I'm just showing you. I'm just showing you what it is, and you see, we have to be very careful of how it is that we round off prematurely. Okay. It's an issue that I have with a lot of students, and I am trying to teach you how. It's when you write your sorry, let me just finish this and show you. I was just trying to break it out for you. You see when you write your answer and get 0.6. All right, put it this way. And I want you to work with me. So I'm a scientist, all right? But if you were to give somebody is going through chemotherapy, and the anesthesiologist calculates something and said it's supposed to be 2/3 of it, and I say, oh, but 2/3 of 0.66666, put 0.6 here. 0.6 is going to be less than what the amount of medication or radiation that the patient is supposed to be getting. So the patient will go through, and the session will have no effect on the patient because the patient did not get the correct dose. And then Jermaine come and say, oh, then 0.6667 or 0.7, and Jermaine round it off and put 0.7. And while you're administering the medication to the patient dead, because guess what? Too much exposure you have to the patient. Not only that, they going to hunt down Jermaine, you know, but Jermaine can lose him license, and appear things are going to happen. Medical malpractice. What's the point? The point is, when you prematurely round off, your answer is not correct, will never ever be correct. So the closest that I got to the correct answer just now was 0.67. 0.67 was the closest. So I'm saying this to you, to answer the question that was asked of me just now, I'm saying to you, as best as possible, get into the habit of writing your answer as a fraction wherever you can get it as a fraction. In the earlier questions when we were doing it, you notice that the calculator never gave us as a fraction. We got it as decimal points. You can go ahead and write those as decimals. But once it is that you can write your question in the fractional form, please put it in a fractional form. Let me show you this before I move into what it is that I'm showing you here. X minus 1 over x plus 2. We're assuming that x is equal to -1. So anywhere in the function I see x, I'm going to put -1. So see it here, -1 minus the 1 that we give. All right. One of the things that I love to do is, because I'm not in front of you teaching, and for me to show you some stuff, I like using my colors because it becomes my hands and my feet. Watch me now, guys. So you see this -1 is what it is that I'm going to be substituting here for x. So see it here, so see the x here, so I'm going to change it to -1. So the x on here, so I'm going to change it to -1. So this now becomes -1 minus 1 is -2. And this becomes -1 minus 2 is -3. And -2 divided by -3. Once I'm dividing two negative numbers, it becomes a positive. So I just drop the negative sign, so it becomes 2/3. So this is why it is 2/3 here. All right. 1 minute. Is everybody in the class understanding? Is there one person in the class that is not understanding?
Clear as mud, boss.
Clear as mud, and I'm very happy for that. I'm very happy for that. All right. Now, you see, I'm purposefully pausing the class here for 1 minute just to help to clear your mind before I move into the last thing for tonight. Whenever you're in a class and you guys are new, well, some of you are new to the bachelor's program. Some of you may be here already for the bachelor's. All right. But for the most part, you are year 3 students for the most part. One of the things that I'm going to encourage you to do as someone who has studied quite a bit, I'm going to explain something to you. Is when in one class, try as best as possible to get 99.9% understanding in the class. I will tell you why. Many of you, and this is prophetic, don't have anybody around you to help you. Is you have to provide a help to others. So when you leave my class and you don't understand the concept that I'm teaching, dog nyame supper. So what I want you to do, when you come to class, don't just come to class and listen and watch a screen. Have your notebook, have your pen and your pencil and your highlighter. And when sir says something that makes sense, yeah, you're not gonna get the recording and thing, but when sir says something that makes sense, you jot it down. You jot it down. And you find out, wait, sir, use a word, I know what the word mean, you write down the word and you go look on the word itself. All right? So this is how it is that we're going to be learning for the rest of this semester. You're going to say to me and speak honestly and truthfully. Nobody in the class can laugh at you. I'm the only one will laugh. Trust me, I love to get a good laugh. And I'm not going to laugh at you. I will never ever laugh at you. But I want us to get into a mode where we understand each other and we can get the best understanding out of it. All right. So honesty is the best policy. When I ask you a question, you're going to answer me honestly. Are you understanding? Yes, sir. Is there anybody in the class not understanding? No, sir, we understand. Good. I am moving on to something that is called indeterminate. Indeterminate. All right. So without Googling it, what it sounds like to you, indeterminate. What it sound like to you?
sir. Can't make up it mine.
Okay, I like that. Can't make up its mind. All right.
Yes.
Anybody else?
Don't have a specific form.
All right. Well, it's unsure, sir.
It's unsure. Nice. Andrew, is there? Well, Andrew is saying that he's not hearing. Everybody's hearing me, right?
Yes,
Yes,
sir.
Yes.
sir.
Yes, sir.
And Andrew, check your device, Papa. My device kind of working out. But if I say that, if you're not hearing me, I'm not going to hear what I'm saying. Let me just. Somebody just put in the chat for me, please. Andrew, check your device, please, and thanks. Yeah, man. All those definitions, I love them. You know, them so nice. Two more. When you hear indeterminate, what mean? Wait, sound like to you?
Indecisive, sir.
Indecisive, undefined. Okay, nice. One more.
Not known.
Say it again. Talk to me, please.
She said not known, sir.
Oh, not known. Thank you. Not known. All right. Guys, so if anybody ever telling you that no don't have no sense or on can't do maths, I want you to write them a note and tell them that the blood of Jesus is against them. Those are excellent answers. I'm really very proud of all of you that answered. Very nice. All of the answers that you gave me, I can use them and use them appropriately. Very
Sir,
nice.
Google it, you know, sir. That's just
I'll Google them.
Where I go, Ryan? Eat some ice cream, Ryan.
Right, you burst them secret, but never mind. It's very nice. Very, very nice. Now, when we're looking at the calculations approach, Sir says, assume that this number is a value of X and you put it into the function. Talk truth. That's what Sir said, don't?
Yes, sir.
Yes,
Very
sir.
good. Very good. And Sir was right. Sir was right. Do me a favor now. This one is, I don't like it right. Let me just put a little space between that arrow and the -3 so that you don't have any. Watch here. Undo. All right. There you go. All right. Now, I want you to take pen and paper this time. This one you can't do in the headspace. I want you to take pen and paper for me now, and I want you to find the limit of that function. Remember what Sir says. You are going to assume we're not doing the intuitive approach. No, we're not. We're not doing the intuitive approach. So Sir says, whenever you get a question like this, you are going to assume that X is the number that it is approaching to. So you're going to assume that X is equal to -3. I want each and every one of you in class tonight to substitute -3 into the function and tell me what to get for your answer.
Sir, can I say?
Absolutely. Go ahead for me, please.
0.67.
You got 0.67. All right. So hold on to that 0.67. And while you're holding on, just double check your answer there for me and confirm, and I'll wait until the other. Charlene, I want to hear from you. Aviana, I want to hear. -8. Okay, hold on to your -8. And while you hold on to your -8, I want you to double check your calculation. Andrew. Andrew, you hear me now, Andrew?
Yes, I am. I came out
Okay.
of the meeting and came back in, and everything is good.
All right, good. Okay. All right. So I'm
Terminal,
seeing
hold on
Amiga.
for it again.
So tell me what you get.
Sir, may I say 42 over -6 million, is that right?
Okay. Me soon tell election.
42 over -6, wrong and strong.
Wrong and strong. All right. Okay, I hear you. Chirian, what you get? Me know you're tired, but tell me what you get. Davia, you don't talk to me since class start. Yeah.
Sir, I'm wrong still now, but me know. I get 0.
You get 0?
Yeah. So say wrong still.
Sir, me get negative.
0?
Negative.
Yeah, that's I'm gonna get 0.
Okay, all right.
Sir,
Who
I
say
get
negative something?
negative 2.3.
You get negative 2.3. All
Yeah.
right.
Or
Okay.
minus
14 over
4, sir.
9.
You
Sir,
get
me get
minus 4.
negative 4. Negative 4 I got, sir.
Negative
See?
4.
Husband and wife.
Yeah, man.
Yeah,
Same
yeah,
as say
yeah.
no. Yeah, man. Same as so.
Sir,
Yannick, you don't talk to teacher yet,
my
Yannick.
answer, sir. I'm
Where
checking
your answer be?
second time.
You check that second time.
See, man, I'm telling you 42 over -6.
Fair enough. All
I'm
right, fair
checking
enough.
again and I see him thing again.
I'm a timetable, man, no.
What time period you do?
Over -6.
Because
24, sir.
I got the fraction form that I got was -6 over 42, but I divide the 42 by the -6 wrong, so I'm gonna say the wrong number first.
Okay, all right, no problem.
Same thing
Sir,
have you done.
sir,
Not
I'm
keep
leaving it the fraction 14
42
over
over
-6.
-6.
Okay, all right. So no wrong and strong. Jeremy, you came in a while ago and said something a while ago, Jeremy?
Sir. Sir?
Yes, please.
I got 0.
Who that?
And a 0, and a 0.
I got 0.
A negative
Can
4.
we take out 0?
Yes,
Negative
sir.
All right. All right. You got 0.
Negative
All right.
4 is the answer.
So Kelvita, how you get 0?
Kelvita, no way I get 0, Kelvita. A negative 3 here. I think that's 3.
Negative 3. All right.
Negative
Okay.
3. So I put 3, I get 0, but the answer negative 4.
All right. Because what don't worry about Shana Lee. You can't come in my class for the first night, you know, and you don't talk to teacher, you know. So you better unmute and talk to teacher, even if it's a good night, sir. Because me called upon you earlier, you know, talk to teacher. Good night, Shana. Yeah, you may talk to you know, Shana Lee.
Oh, I don't know. This damn internet keep on chipping in and out. But however, I got
No, careful. Because next you go say one next word.
0.
Careful. We are being recording. PG-13. You get 0?
Yeah.
Oh, you forget 0.
I don't know. 9 plus -21 plus 12 give me 0 divided by -6.
Yeah, that
Right.
we get 2. All right, we're not strong.
All right. No. No, Jeremy. No, Jeremy, but you change your answer to
Jeremy, don't change your answer.
No,
It's
4.
negative 4.
No, 4 matching mental, not negative 4.
All
4.
right.
4.
So
4.
Anyway,
sir?
Me nervous, sir. Tell me answer.
4 matching.
You're nervous?
Final answer.
All right. Okay. I'm just checking to see what it is that I have here. All right. So, all right. So, I think I was checking to see if I wrote the right question. So that's because I don't understand where. All right. So the point is, there are 2 students who got it right. Well, 2.5 students who got it right.
42 production.
6. 42 over -6.
And Lexton, you are the weakest link. Goodbye.
Wrong and strong.
It's me and Ryan.
Next time it's incomplete. That is what Sir is saying.
No, the final answer -7, but in
Lexton, be
Lexton,
quiet.
Lexton, do me a favor, Lexton. You
Yeah.
put on the kettle and go boil a cup of tea because that's not right.
All right,
All right.
wrong and strong.
Wrong and strong. But me like it energy, you know. No, it's for the rest of the class, we're gonna mute Jermaine because Jermaine had the correct answer as 0 and
Not
3.
the off, sir.
Right? So Jermaine a flip-flop. So he might off, of course. The boy
No,
play
but
off.
same answer no.
No, Jermaine,
Four.
Jermaine, 4 wrong.
So 0 right answer.
Duh.
So that went right before?
Uh-huh.
You should have
Work it
stay
out,
away
Mama
there. You
Tigger,
think
sir.
a greener pasture over there,
So
sir.
work it out, Mama Tigger.
I Charlene,
Work it-
yes, sir. I Charlene.
No, leave Charlene alone. Don't push
Exactly.
Charlene into it. Don't push Charlene into it. Right? So you have what it is that you want, what you think say something over there is nicer.
Yes, sir.
And
I'm going over.
yeah, man.
The
And you
meal
get
look
catch.
nicer. I'm
Yeah,
getting
you get catch. Okay, you?
Ryan and Charlene.
Oh, yes, you have to answer it, sir.
Next one is still talking.
No, Ryan, more.
Ryan, sir.
Ryan, Ryan, you know, get the answer, Ryan. All right,
The answer,
come,
yes,
let's-
that's 0 the answer.
Yeah, 0, yeah, man. All right, come, let's go. So we have. Let me just copy this one. Copy and paste.
Sir,
So remember, you
the
know.
letter that makes sense to me.
Me said no. Next time, let me tell you something, man. I'm proud of you, man. Anything you eat at daytime for lunch, eat it every day. No, man, I'm proud of you, man. Really, really, very proud of you. Keep it up, CDB. Really proud of you, man. All right, let's go. So remember what teacher says, you know, teacher said, any number you see down here, so you're going to assume that it's going to be the x value and you're going to substitute it anywhere you see x in or something, yeah?
Sure.
So watch this now. You're going to say x here, so you're going to put -3. So one next x right here, so again, you're going to put -3. And watch this. -3
Sir,
squared.
have a plus in front of the 7.
I didn't. And that's why I was looking at it to see if I made a mistake.
But a plus never in my book.
Oh, maybe that's why you made the mistake. You see, that's why when teachers say, when you write out the question, you have to look on the question with upon something, because you are the one different question from me. So maybe that's why you gave me the answer you gave me. Lexton, check to see where you write out, because maybe that's why you gave me the answer like that to Lexton.
No, I don't mean I'm
Sir,
saying.
you get the right answer first. I him go mix up in brain.
Mix up in brain. All right. -3 squares is going to be equals to 9. -3 squares is going to be equals to +9. All right. And -7 times a -3.
Sir, Cree, sir. Because my calculator give me -3 squared as -9.
Ryan, because I don't put it in the bracket.
I have to put it in the brackets. All right. And I kind of suspect what is happening here. Remember I had stopped and was checking my answer here. And maybe there's an error right here, and maybe that's why Lexton was giving me his 42. Lexton, what you said? They said 42 over -6. Lexton.
Yeah, that's how I get. Yeah.
Yeah, man, and I see why I get it, because oh goodness, who was it a while ago asked me if it's supposed to be a +7? Somebody asked me a question a while ago. All right, guess what? Let me move on from that one. I'm going to fix this one.
Sir, so you're not going to complete it?
No, I'm going to fix it. Time is running, and incidentally, nobody don't ask if you know break on a 9:49 here. You have 10 more minutes.
Sir, my thing is, if you left it as it is,
Come on. No, man, no, there's an error with that question. I'm going to fix it. I'm going to fix it and take it back to class next time around. But what I want to bring across this point in class tonight, and I'd have to go and fix this one. But I want to bring across this point in class tonight. So I want you to look at this one now. So forgive me for this one. But I want you to look at this one. Yes, honey.
Biggie fight.
Bigified. All
As
right,
you
it's a
said.
bigified. Yeah, it's a bigified. I want you to look at this one here, number 2. And let me just do number 2 quickly and just make sure that it. Yes, number 2 is all right. So do me a favor now, and everybody should get number 2 right now. So take a minute, 1 minute, and substitute x to be equals to 3 in this one here, and tell me what to get. 1 minute.
Sir, none can divide by 0.
So tell me the answer. What the answer you get?
0.
0.
Whoa.
All right. Very good. So this is the point I'm trying to make, and I'm happy that you're seeing this one. I'm going to fix that top one up there and come back to class with it on Tuesday, all being well. So look at what is happening here now. So this is what I want to do. So you are given a question. You are given a question, and I don't want you to see that just yet. You are given a question. Let me just copy this. Bam. And you are using the algebraic approach. APPLY, applying the algebraic ALGEBRAICAPPROACH. So you are doing the algebraic approach here. And for the algebraic approach, you're substituting 3 into this function. So anywhere in the function you see x, you're substituting 3. And I like what the person say, but sir, you can't divide by 0. Like, duh, 0, one of them numbers here where you just say you can't divide by. Yeah, man. I agree. But look at what is happening here. Here I'm going to have 3 times 3 is 9 equal case. So we have 3 times 3 is 9, and negative 5 times 3 is negative 15, don't it?
Yes, plus 6.
Plus 6. And 3 minus 3 are 0, don't?
0. Mm-hmm.
So we're going to have 0 over 0, don't?
Lord, we know say 0.
You just know say 0.
That is
all right.
correct, sir. 0, 0.
0 over 0. No, you see that form 0 over 0, which is a point I was trying to make. 0 over 0 is the indeterminate form. The 0 over 0 is an indeterminate form. No, all of the definition will give me right to know. You can't work it. Sitting on right. Something is hiding something.
Sir,
yes, Papa.
I must use the scroll up back a little bit. Since I use the indeterminate approach, most times it will be 0.
If you no, it's okay. So they're not going to tell you that is the indeterminate approach or the indeterminate form. You will have to find out whether or not it's indeterminate, right? So the point I'm making is, you notice I put this thing up here, applying the algebraic approach right here. So because whenever you get these questions, you are going to try the algebraic approach, but when you work it out and you get 0 over 0, you are going to say indeterminate, INDETER.
So, sir, if you do it right, indeterminate, you lose mark.
No, but you see, no man, you're not going to lose mark. You're not going to lose mark. Matter of fact, you don't even get a mark for this because you now need to know that it's indeterminate. That means there is something in the function that is preventing the true limit of the function to come out. So once you get, and there are several indeterminate forms. 0 over 0 is just one of the indeterminate forms. Well, I shouldn't say several.
Sir.
There are 2. Yes, Papa.
Sorry. Just like my learned friend realized that the new what's that? Numerator, which one on the bottom there, sir?
Denominator.
Yes, denominator was 0.
You can't have 1 0 down there, don't.
Right. Isn't that would you need to go any further? Because since you can divide by 0, would that not be indeterminate?
Good question. So if you have to be careful though, because when you look at the function, what if the numerator was 5 and the denominator is 0? What would you say your answer is?
No, divide by 0.
Yeah. So if you have 5 over 0, what is your answer?
0.
0.
No.
5 over 0?
Yeah.
5 divided by 0, sir.
if I clap with anybody who tell me 5 not eat no dinner tonight, them dinner not gonna taste as good tonight. Anybody who say 5 and them eat them dinner, it not gonna taste good.
5 over 0.
Put 5 divided by 0 in the calculator and tell me what you get.
0.
0.
Take your calculator and throw it in the garbage pan then.
Cannot divide by 0.
So it's an error.
Good.
Divide by
Very, right. Very good. It can't be divided. So if you get a number in the numerator, and listen to me, because when I reach there, so I am going to say to you that I said to you tonight at the 10 o'clock class that it can't happen. So when you have a number in the numerator and a 0 in the denominator, we are going to say that it is undefined. You can't define it.
That's sir.
Whenever you have a 0 in the denominator, the function is not defined. It is undefined or infinity. It's undefined. Undefined.
Okay.
You can't define it. There's no way you can have a 0 in the. Think of it this way. You can't build a house on a round stone, because when you open the front door and step in, the house will go tip over or topple over. What you'll do is you'd have to go open the door and jump right into the middle of the house. Who does that? You can't have a 0. So it's undefined. All right. So I'm saying to you, the question that was asked, then, sir, from the denominator, and say it's 3 minus 3, sir. You know it's indeterminate. No, because a question can come in such a way, and I can give you a question like that, where in the numerator you have a number other than 0. So what you're going to say to me when I ask you to evaluate the limit, you will then say to me as your answer, sir, it is undefined. Why is it undefined? Because you have a 0 existing in the denominator. All right. So let me use these 3 minutes to just go through here. So you have to show me the 0 over 0. The 0 over 0 is the indeterminate form. What does the indeterminate form say? The indeterminate form says that there is something in the function preventing the true thing from coming out. Put it this way. Boy meets girl, but boy never have a good relationship with his father. Or boy sees father beating mother. So boy thinks no that it's the normal thing, and when girl seemingly not conforming, boy want to lift up his hand for lick woman, because it's what boy sees. But inside, the girl will say, he is a good person, but he has this limitation about him. And incidentally, men, you're not supposed to hit your women, you understand? And women too, please do not hit the men, right? And the woman may say, sir, me love him, you know. The only problem I have is that him lift up his hand too much to lick me, but everything else about him is all right. You understand? This is what the question is saying. When you have the indeterminate form, it says that there is a limit for the function, but there is something about this function. Drink too much Jerry and his nephews. So I forgot to take one whites. I tell you. So you have to take one little whites, and then you can see the true person when him sober. Watch me. When I look at the function x squared minus 5x plus 6, and I factorize it, I'm going to get x minus 2 times x minus 3. I'm going to get x minus 2 times x minus 3. No, my x minus 2 times x minus 3. When I look at that, then what I can say to you is that the x minus 3s, come on, don't do this to me now. The x minus 3s will cancel out. The x minus 3s will cancel. So I can safely say to you, what was causing the problem in the function was the x minus 3. Now, somebody a while ago asked me, but sir, once me look on x minus 3 as 0 in the denominator, me can't tell it says indeterminate, and sir said, no, it can't be, because I can have another number in the numerator. However, the mere fact that you have an x minus 3 and the limit tends to 3, it means that there is an x minus 3 hiding somewhere in the numerator, preventing the true limit of the function to come out. So look here, when you factorize a function, stop it. When you factorize a function, you recognize that in fact, there's an x minus 3 hiding somewhere inside here for truth. So now we can take out the x minus 3. You know what I'm left with? only x minus 2. So what we can say now is I am now finding the limit as x minus 2. And we're going to go back to applying the algebraic approach. We're going to assume that this x is this 3. So we're going to say 3 minus 2 equal 1. So the limit, the answer is 1. Now remember, where we're coming from? We are coming from 0 over 0. Indeterminate, meaning that there is something in the function preventing the true limit of the function to come out. I now need to isolate that something. I can either factorize, I can simplify, or I can rationalize. In this case, I have to factorize. That's why I said to you, coming soon, factorization. So when I factorize, Numerator. So factorize the numerator, all right? And then now when you factorize the numerator, you're going to get out the x minus 3, then you're going to left with the x minus 2. This x minus 2, you have now reduced the limit. You have isolated. You have a bad egg in the batch, right? And that bad egg is causing the other eggs to go bad. So you have to now isolate those bad eggs so it is that you can take it out so that the others can stay afloat. See it here? And I'm going to have the x minus 2. And when I substitute my 3 in there, I'm going to have that. And then I get my answer here to be 1. And that's the end of that question. That's the end of the class. 2 more minutes for me.
Sir, I'm gonna
Yes,
miss for
please.
the blink or what? And miss
Don't.
when that happen, but where does +6 go?
The +6?
Yeah.
Magic. All right. What I will do for you, I'm going to send you this page. You see? I'm going to send the class, not just you, but I'm going to send the class a page. What I'm going to do, I'm going to do the factorization. I'm going to do the factorization. Show workout. I'm going to do the factorization for you and then send you this question so you can have it to look at in the WhatsApp group. All right? I don't want to extend the class I don't want to extend the class any further because I did say to you that. But I'm wrapping because I know it's late. Me just getting very energized because as I said to you, I get very excited when it is that I'm teaching and especially when students are learning. No, I want to ask you one question. I know somebody I think it was Ryan who was saying, sir, we can't get a break. Ryan, come, unmute, Papa. Talk to teacher.
Sir?
How you feel? You feel like you didn't want a break?
No, that's sweet.
That's exactly what I told was going to happen. It's when you're learning and you're understanding. I know it's when 9 o'clock came and I saw the time. I said, I'm not saying anything to anybody. And I'm going to see if anybody going to say, sir, it's 9 o'clock. Nobody said anything. So for those of you who are just joined.
I will say it, but we never say it to you.
You never say it to you. Oh, you say it to yourself and say, Lord Jesus at 9 o'clock. In your brain. All right. But for those of you who are just joining, because this Calculus 1 and Calculus 2 are 60-hour long courses. Calculus 2 will be fine because Calculus 2 will be done in a semester where you have your 15 weeks. We have only 12 weeks in this semester, so we have to put an extra hour on your timetable. So that extra hour comes on a Thursday instead of 7 to 9, we'll go 7 to 10. I enjoyed my class tonight, and particularly, you guys were understanding. And because of that, before I go to bed tonight, I'm going to finish off. I'm going to do the factorization here and send off to you in a WhatsApp group so you can have it. No, you have to promise me that whatever I send in a WhatsApp group, you're going to be looking at it. Just go through it, make your notes, and you come back to class and say, sir, I don't understand something right here. But it is very, very, very important that you go through the stuff. You've been a wonderful set of students. I'm going to ask that you have yourself a good night, sleep tight, see if you can go to bed now, get up early before work, and even put in. For those of you, man, and try it one night and trust me, your butt. Yes.
Sir, once me go sleep, when I get up to my phone alarm.
Sir, you teach calculus too?
Say it again.
You teach calculus too?
Yeah. I had a summer group in calculus too.
We're requesting you. We're requesting you for calculus too, sir.
Let's book our class on now, sir.
I can't do that because
sir, your department.
We are going to the department. We are requesting you.
Okay,
Or
we
do
have
we
this
request?
one.
Let us go through the training. Or do we request you?
Yes,
Black,
right.
Do me a
out
favor.
Chelsea again.
Uno go on a bed here and have a good night when you get up and do some work. And listen to me. Don't let me put an alarm on the clock, and send the messages early morning, All right, guys. A wonderful bunch of students. You make me proud here. We'll talk. All right,
No,
take care,
sir.
guys.
I'm requesting that you work out number 1 as how you have it, so the saints who felt dunce at the back can know if they did right or wrong.
Unique, leave me alone, no? You're not at work tonight, we can't talk.
Sir, I second that one.
No,
Yes, sir.
All right, okay. All right, okay, fine. I will. All right. We'll be, guys. Bless in the heart here. Take care.
Bye, sir.
All right. Yeah, man. Easy.
Bye, sir.
Bye-bye.